Welcome to the 50-year celebrations for the American Journal of Sports Medicine, where we are counting down the top cited article for each year. My name is Kate Webster, and on behalf of AJSM's Electronic Media Editorial Board, I'm pleased to present the article for 1983, which is titled Articular and Ligamentous Contributions to the Stability of the Elbow Joint. And to discuss this paper, I'm joined by the lead author, Professor Bernard Mori. Professor Mori, congratulations and thank you for joining me.
Thank you. I very much appreciate your interest in this work, and I think you've got a very interesting project that you're developing.
Can you tell us a little bit about the background for the study?
Well, there's a couple of things to consider. The first is I had just joined the Mayo Clinic a few years earlier after doing my military obligation. And I was interested in athletic type of injuries. But I was very interested in the elbow because during my training and early in my practice, it was obvious that it was kind of the ignored joint. There was very little in the literature regarding the elbow. And so as an anatomic area, I was interested in that particular joint. And there was so little known. One of the key questions that relates to any joint is its stability. And in the sports world, this was a little before Frank Jobe had described the Tommy John procedure, but it was in that era. And so there was a great deal of interest in the sports world about injuries to the joints that resulted in instability. There was also on the trauma side issues regarding the radial head of the elbow and its role in stability. So there wasn't very much science that directed the clinician as to the proper course of management. And so we started this project just to provide some insight as a starting point with further refinements that could be developed in the future.
Excellent. And I'm just going to show some pictures from your article. Here are some pictures of your material testing machine from the paper. I'm interested to know what were some of the technical challenges you faced with this study?
Well, the first challenge was the analytical challenge. When you're looking at relative contributions, the manner in which the contribution is defined is critically important, because if you don't have the sequence of alteration of the construct properly defined, then you will not properly represent the relative contribution. I know that didn't mean a thing the way I said it, but there's two basic approaches to defining a joint stability. And with the testing machine being shown, one of them is called a force-based assessment, where you impart the same force each time and with different amounts of releasing the constraints, we can see how much it displaces. So it's a force controlled, and the output is displacement. The other is displacement control, where you displace the joint in one dimension or the other, and look how much strain is in the ligaments or forces go across the joint, and that tells you the relative contribution. So that's fairly technical, but that was the challenge we faced. The second, which does relate to the figure a little better, is we had to impart a certain displacement, but we had to allow the elbow to rotate and displace in two. We would introduce the force in one axis, but it's three-dimensional, so it had to be able to rotate along the other two axes. So we had to design a fixture that would allow that rotation. And then finally, the sensitivity of the measurement exceeds what you can do grossly. So we measured the displacement electronically. So that's those wires that are coming off that machine. So this was the first time, I think, a force displacement analysis had been conducted on the elbow. And so we had to design the fixtures, and it took a little while to get it properly oriented, if you will, so that we could generate the data that we generated in that article.
Thank you. So why do you think this paper has been so impactful in the field of sports medicine?
Well, as I told you earlier, I was totally surprised to learn this, but I was very pleased. I think it was because there was a void. People were replacing radio heads, but we didn't really know the radio head's contribution to the elbow and to the elbow stability. If you take it out, the elbow will drift into valgus, but it wasn't really very well understood. And like I say, the Tommy John procedure was designed in this era, and so there was an awareness of ligamentous injuries in the athlete, not just a dislocation, but a strain. And so in answer to your question specifically, I think there was a void. There was no scientific evidence that addressed this at all at the time. And so I think when something like this comes out, and we, to be very honest, we made it very simple. It was not a sophisticated analysis with curves and well, it was a sophisticated analysis, but we tried to portray it in clinical terms so it could be clinically useful. More useful to a clinician than to, you might say, a researcher that wants to take it and go another step. It actually, I think, was pretty easily understood and adapted by either the clinician or the investigator. And that probably was one of the things that attracted people to it. But to be very candid, we designed it to be that way because I'm a clinician. I have a master's in biomechanics, but I'm a clinician. And so I wanted this information for my practice. And I knew my partners and my colleagues wanted it too. And it didn't exist before this article.
I think that relates to the final question I wanted to ask you. The conclusion stated that these data would provide the scientific basis for clinical practice. So in the almost 40 years that has now passed, can you comment on any clinical applications that have resulted from this pioneering work?
Well, that gets a little bit tricky because you have to factor in other things other than just this paper. But one of the applications that I think is relevant, it's not in so much in the sporting world, but one of the major problems we have with trauma is when the joint surface gets fractured and the elbow gets dislocated. So the injury involves both the articular surfaces, which are referred to here, and the ligamentous structures. And one of the biggest questions, even to this day, is how much of the coronoid, which is the other part of the joint, not the radial head, can an elbow suffer the loss of and still be stable? And so this article didn't address that, but subsequently we did study that and define what that was. But that all had as its precursor this study, which was the first to look at the relative contributions of both. And so that's one area that I think is very relevant. The other is how do you manage the radial head fracture? And this article showed that if the medial collateral ligament is intact, the elbow is not particularly unstable if the radial head is gone from a fracture. On the other hand, if the radial head is fractured or is not present and you lose the medial collateral ligament, then there is a significant instability. So it showed the relative contribution of the radial head and the medial collateral ligament and the sequence. If the head was gone, the medial collateral ligament was adequate to stabilize the elbow. But if the radial head was gone, then the medial collateral ligament had to be there or the elbow would be unstable.
Thank you very much, Professor Mori, and happy 50th AJSM.
Well, thank you very much. I'm looking forward to the meeting that's coming up. I'll be at that meeting.